Today's video here is a nice problem. It's coming from International Mathematics Olympiad edition 1990. Here is the following fraction. Here is the following fraction. We have 2 to the n plus number 1 is divided by n squared is an integer or is a natural number. So the question, we are going to determine all the values of n as a natural number in order to have this whole fraction as an integer. Okay? You guys, you can give the hands to this problem prior again to solution. Go ahead, pause this video when you come back to see the full solution. By the way, don't forget to hit the subscribe button and support the channel by like and the comments. So now let's go ahead and get started with this one. So the first observation that I'm going to extract from the setup, we know the odd because this one is an even plus number 1. So which means denominator must be odd as well. We cannot have odd in numerator while we have n is an even denominator. Okay, so which means, so we get here 2 to the n plus number 1 all over n squared, which equals m as an integer or natural number. So which means this one is telling us n must be odd. Since this fraction is a whole number, which means n squared must be divided 2 to the n plus number 1. Okay, let's make a nice combination here with this property divisibility and with a new prime number. Okay, so simultaneously, since we have this one is a odd, you may have a smallest prime can divide this n square. Okay, so because as we going up in n values, you may hit the prime numbers can divide this n. Okay, so let p to be the smallest prime which can make such that p is going to divide n, okay, at some point. The smallest prime here, it doesn't mean the smallest value as we start the prime numbers 3, 5, 7, which means now we are going to find out the intersection point of p and n where we have the divisibility occurred with this p and n. I'm going to use these two properties. We have here two things. We have n squared divides 2 to the n plus number 1, and also we have p divides n. Since n squared divides 2 to the n plus number 1, this one is telling us n divides 2 to the n plus number 1. Okay, big divisor here divides this number, which means the smallest divisor can divide this one as well. So, and let's take these two facts together. P divides n. So these two things we can conclude p is going to divide 2 to the n plus number 1. This one is called transitivity divisibility property. Okay, so by the definition of the divisibility property, so we get 2 to the n plus number 1 is a congruent to 0 mod p, like this. I'm going to take this number 1 to the right. I get here 2 to the n is a congruent to minus 1 mod p. Here is the first fact here. So this I'm going to call this one number 1. So the next fact, this written is telling us p not divides 2 to the n. Okay, so by Fermat-Leroy theorem, this one is verifying the Fermat-Leroy theorem. This one I will have 2 to the n all to the p minus number 1 is a congruent to 1 mod p. Okay, I'm going to switch this exponent here, so I will have 2 to the p minus number 1 all is raised to the n as a power is a congruent to 1 mod p. So this one equivalent, I'm going by taking this n off out of this exponent as we have an odd here, so we get 2 to the p minus 1 is a congruent to 1 mod p. Now we will have two facts here. This is fact number 2. So this statement number 2, this is statement number 1. Okay, P divides N. Okay, which means P minus number 1 cannot divide N. Okay, by the Bezout theorem, exists X and Y as a natural number. So I'm GCD of P minus number 1 and N equals 1. Okay, so this one is telling us by the Bezout, I get X is multiplied by N minus Y is multiplied by P minus number 1 equals GCD of P minus 1 and N, okay, which equals 1. Okay, the reason why I put minus sign here, because I'm dealing with a natural number. You can put a plus sign here while you have X, Y as an integer, because I'm putting the minus sign here because in fact this one it comes with a plus sign because we are dealing with integer numbers. Since I have chosen X, Y as a natural numbers, so I'm going to put a minus sign here, because now we have no choice. You have to put a minus sign while we have this Y and X as a natural numbers. So now I'm going to put this fact together with this fact as a statement number 3, as I get X N, which equals Y is multiplied by P minus number 1 plus number 1. Okay, so let's call this statement as a statement number 3. I'm going to take these 3 facts at the top and continue solving our equation. Now at this moment I'm going to combine these 3 statements together in order to extract a nice expression here. Okay, is a congruent to the 2P minus number 1. Okay, I'm going to raise both sides to the Y as an exponent. At the same time I'm going to multiply both sides by number 2. Okay, I'm going to put this one as an exponent, so I get here 2 to the Y is multiplied by P minus number 1 plus number 1. Okay, so by the Bezout theorem we have extracted this expression. We get Y is multiplied by P minus number 1 plus number 1 equals Xn. Okay, so this one is a congruent to the 2 to the Xn. Okay, so I'm going to put N as an exponent here as well. X as an exponent, I get 2 to the N, all is raised to the X. I'm going to replace 2 to the N with minus number 1, since we have this one is a congruent to minus 1 mod P. So this one will be congruent to minus number 1, all is raised to the X as an exponent mod P. So now we need to know the exponent is odd or even. Okay, so let's go back to the original equation, this one. We know this term P minus number 1 is even because we know P is an odd prime. Okay, which means the product of Y is multiplied by P minus number 1 is even, plus number 1 becomes odd, which means the right hand side of this equation is odd, which means left hand side of this equation must be odd. Okay, since this one is odd, which means N, we already know N is odd, X must be odd. So if X is odd, this minus number 1 is going to be minus number 1 mod P. Okay, also Y to the 1 it will be cancelled out to number 1, so I get here 2 is a congruent to minus number 1 mod P. In the other word, by taking minus number 1 to the left, I get 2 plus number 1, which equals 3, is a congruent to 0 mod P. Okay, this one is telling us P divides 3. Since P is a prime, which means P equals 3, and also by previous information we know P divides N. Okay, this one is arithmetically N must be equals 3 because P is a prime. Okay, now we have extracted the value of N, which is verifying this setup. So if I'm going to replace N with number 3, I get 2 to the 3, which is 8, plus number 1, which is 9, 9 over 9, which is 1, which is a positive integer or natural number. So I have ended this video. By the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.